Hello, this podcast is about quantitative analysis of force vectors. First, we're going to learn about some key terms. We're going to take a closer look at total forces and their component forces. Then we're going to learn how to quantitatively analyze these total forces and component forces using the physics Pythagorean formula, using trigonometry. So let's look at some things we need to know. First, total force, that's the actual force acting on an object. So if I'm pulling a rope up and to the right, the total force would be that tension force of me pulling on the rope. The resultant force, that's just another term for the actual force. So resultant force is a synonym of total force. Then we have our component forces, and these are two perpendicular parts of a total force. So for instance, if in this example the force was me pulling a rope up and to the right, one component of the force would be horizontal to the right, and the other component would be vertically up. And what's important about these component forces, if these two component forces were exerted on the object instead of the total force, the object's motion would be the same. What's important about this is that we can break down a force that's at an angle, we can break it down into its force in the vertical dimension and its force in the horizontal dimension. The x-component force, that's the part of the total force that lies on the x-axis. It is usually parallel to the surface, or we sometimes call that the horizontal component. The y-component force, that's the part of the total force that lies on the y-axis. It is usually perpendicular to the surface and is often called the vertical component. The directional angle is the direction of the force expressed as an angle measured counterclockwise from the positive x-axis. The symbol we give for this angle is the Greek letter theta. And finally, we have the magnitude, and that's the strength of the force, and it's measured in newtons. Let's take a look at total and component forces. So we have a total force, and we would say that this force is going up and to the right, and we can break it into its rightward component, or x-axis component, and we can break it into its upward, or y-axis component. We know that we can give it a direction by the angle theta. So we would measure this angle, and that would tell us the direction of this total force vector. Notice that this total force vector, the x-component force vector, and the mirror image of the y-component force vector create a right triangle. And that's important because that can help us determine the strength of the x-component and the y-component. Because for every angle theta, the x and y component forces are a known ratio of the total force regardless of the triangle's side. So for instance, if this total force was half as strong as shown here, the force vector might stop right here. Well, we would have a shorter or weaker y component force, and we'd also have a shorter or weaker x component force. However, they would be the same ratio compared to the total force as in this larger triangle here. So it's a known ratio based solely on this angle theta. Doesn't matter how strong the total force is, the x and y components will be a fixed ratio based on the directional angle theta. So let's take a look. Suppose theta was 30 degrees from the positive x-axis measured counterclockwise. The x component would be 0.87 of the total force, or 87% of the total force. And the y component would be 0.50 of the total force, or 50%. Now we're going to move on and learn how to use trigonometry to accomplish the same thing. An important concept in trigonometry is the unit circle. So let's just take a look at this. And this is the version that you'll see in math class. It's called a unit circle because the radius of the circle is 1 unit. So that could be newtons if we're looking at forces. And it shows us for different angles what the XY coordinates are. For instance, at angle 0, the X coordinate is 1, the Y coordinate is 0. If we draw a line at a 30-degree angle to the edge of the unit circle, its X component is the square root of 3 divided by 2, and its Y component, or its Y coordinate, is 1/2. If we go over here to say 135 and we draw a line at an angle of 135 degrees to the edge of the unit circle, we'll find that its X coordinate is negative square root of 2 divided by 2, and its Y coordinate is the square root of 2 divided by 2. And we can see that for several different angles here. So the important thing to take away from this is that for every angle theta, the X and Y coordinates are known ratios of the circle's radius, regardless of the length of the radius. So for example, if we look at 60 degrees, and let's go ahead and draw that force vector at 60 degrees, and we draw its X and Y components. The unit circle tells us that the ratio for the X component is going to be 1/2, and the ratio for the Y component is going to be the square root of 3 divided by 2. Now, in physics, we like to work with decimal format rather than fraction format. So of course, the X component ratio is 0.5 and the Y component ratio is 0.87. If theta is 210 degrees, and we'll just go ahead and draw in our total force vector at 210 degrees, and again that's measured counterclockwise from the positive x-axis. And we'll draw our X and Y component forces. We can see here, if we go to the unit circle, the X component is a ratio of negative square root of 3 divided by 2, and the Y component force is a ratio of negative 1/2, and if we convert those into decimal format, the X component ratio is negative 0.87 and the Y component ratio is negative 0.5. Let's go ahead and tie this into our trigonometric functions. So for every angle theta, the X coordinate ratio is equal to the cosine of theta, and the Y coordinate ratio is equal to the sine of theta. So cosine and sine are trigonometric functions. You'll find keys for them on your calculator, and you would use those keys just like you would use the multiplication, division, addition, and subtraction keys. Let's take the angles of 30 degrees and 210 degrees from the previous slide with the unit circle and see if our trig functions of cosine and sine give us the same ratios. So for 30 degrees, if we take our calculator and we do cosine 30 degrees, we're going to find out that the answer is 0.50. So that would be our ratio of the X coordinate. And the sine of 30 degrees, we're going to find out that that is 0.87. So go back to the previous slide and check, and you'll see that these ratios are the same as if we used the unit circle from the previous slide. And let's do the same thing for 210 degrees. So using our calculators, the cosine of 210 degrees is going to be equal to negative 0.87, and using our calculator again, the sine of 210 degrees is going to be negative 0.50. Pause and go back in this video and check these ratios against the unit circle for 210 degrees, and you're going to see that our trig functions of cosine and sine give us the same ratios. We've been using the unit circle, and of course that has a radius of 1 unit, or in the case of force, we could think of it as having a radius of 1 Newton. What do we do for a circle with a radius of r? Well, in that case, the X coordinate is going to be equal to the length of the radius times the cosine of theta, and the Y coordinate is going to be equal to the length of the radius times the sine of theta. So let's tie this into how we use it with forces. Here we have a force with a strength of 20 newtons, and it's in a direction of angle theta. And we go ahead and draw in our x component and our y component. To find the strength of the x component, we take the strength of the total force, F, and we multiply it by the cosine of theta. Similarly, to find the strength of the y component, we take the strength of the total force, F, and we multiply it by the sine of theta. Let's do this calculation for an angle of 30 degrees. So the directional angle of the total force vector is 30 degrees. The strength of the total force vector is 20 newtons. To find the strength of the x component, we're going to plug in 20 newtons and 30 degrees, and we crunch this equation in our calculator, and we find out that the strength of the x component is 17.3 newtons, and it is in the positive direction, or going right on the x-axis. For the y component, we also plug in 20 newtons and 30 degrees. However, we're using the trig function sine instead of cosine. We use cosine for the x component and we use sine for the y component. When we crunch this in our calculator, we find that the strength of the y component is 10 newtons, and it too is in the positive direction. It's going up on the y-axis. So let's use our trigonometric equations to solve some more problems. Find the x and y components of the tension force. So here's a tension force. It's 60 newtons, and it's going up and to the right at an angle of 57 degrees. To find our x component, we plug in our total force strength, 60 newtons, and our directional angle, theta, which is 57 degrees. And we use the cosine of 57 degrees times 60 newtons, and we find out that the strength of the x component is 32.7 newtons, and it's acting in the positive direction, or to the right. Similarly, for the y component, we use the sine of 57 degrees instead of the cosine of 57 degrees. We multiply it by the strength of this total force, which is 60 newtons, and we find out that the strength of the y component is 50.3 newtons in the positive direction. Let's look at a problem that involves an object on a sloped surface. So when we have a sloped surface, gravity is no longer on the y-axis, and we need to first calculate its directional angle, theta. And here's our formula for doing that. Theta is equal to 270 degrees plus or minus the angle of the slope. We need to go to our force diagram to decide, is it plus or is it minus? So we start on the positive side of the x-axis, and we're going counterclockwise, 90 degrees, 180 degrees, 270 degrees. We're still not at the gravity vector, so we know we have to go beyond the y-axis, beyond 270 degrees, and the amount we're going beyond it is the amount of the slope. So in this case, we're going to use 270 degrees plus the angle of the slope. So we find out that the directional angle of the gravity vector is 295 degrees. Armed with that information, we can use our equation to find the strength of the x component, and it's going to be 296 newtons in the positive direction. The y component is going to be 634 newtons in the negative direction. Let's move on. So we've learned how to find the strength and direction of the x and y components. Now let's do the reverse process. Suppose we know the strength and direction of the x and y components, and we're asked to find the strength, also known as the magnitude of the total force. Well, for this, we're going to use a version of the Pythagorean theorem, and let me just explain how we can do that. If we notice our force vector here, our total force vector, and we have our x component vector and our y component vector. If I take a mirror image of the y component vector and have it over here, notice that this forms a right triangle. And in math class, we would call this A, we would call this side B, and we would call this side C. And we know with a right triangle of sides A, B, and C, We know their lengths are related by the Pythagorean formula, which tells us that the length of side C squared is equal to the length of side A squared plus the length of side B squared. If we want to find the length of side C, we just need to take the square root of both sides of this equation, and we're left with this formula. And I call this the physics version of the Pythagorean theorem, because notice C is the strength of the total force, A is the strength of the x component force, B is the strength of the y component force. So to solve this problem, to find the strength of the total force vector, we're just going to go ahead and plug in the strength of the x component and the strength of the y component, crunch those numbers in our calculator, and we find out that the strength of the total force is 14.4 newtons. With trigonometry, we can also find the direction of the total force. So this is the same force that we had before, and now it's asking us to find the directional angle theta for the total force. So we're asked to find this angle. And let's look at a new trig function called tangent theta. And the tangent of theta is the ratio of the length of the opposite side divided by the length of the adjacent side. Well, in a right triangle, this is the adjacent side. We would know it in physics as the x component. And the opposite side is just a mirror image of what we know as the y component. So in the physics version, we can say that the tangent of theta is equal to the ratio of the y component's strength divided by the x component's strength. But we're interested in theta. We need to do a little more manipulation to this equation. If we take the inverse tangent of both sides, that leaves us with theta is equal to the inverse tangent of the ratio of the y component and x component strengths. So let's go ahead and put this into action. And we substitute our strength for the y component, that's -8 newtons, and we substitute our strength for the x component, which is -12 newtons. And I should say we also need to put in the directional sign. So we're not only doing the strength, but we have to use the directional signs. When we put this in our calculator, we're going to get an answer of 33.7 degrees, but that is not the only answer. That's the calculator answer, but there is one other answer. The inverse tangent function does not give you a unique solution. There are two possible solutions. One is the answer your calculator will give you. The other one is the calculator answer plus 180 degrees. So the other choice is to take our calculator answer of 33.7 degrees and add 180 degrees to it, and that gives us an angle of 213.7 degrees. Now, which one is correct? We need to go back to the force diagram to look at this. Notice that the y component is in the negative direction and the x component is in the negative direction. So that means that this force vector is in quadrant 3 of the Cartesian coordinate system. Whenever both components are negative, you're going to be in quadrant 3. This angle, 33.7 degrees, is in quadrant 1. This is the angle that's in quadrant 3, 213.7 degrees. So we know it's not the calculator answer, but in this case, it's the calculator answer plus 180. Let's take a look at one more problem. Here we have a plane and its engines are exerting a thrust force of 6,500 newtons to the right on the x-axis, or we would call this to the east. The wind is exerting a thrust force on the y-axis, down on the y-axis, with a force of 1,600 newtons. We would call this south when we're talking about a plane. And the question's asking, what is the strength and direction of the total force acting on the plane? First, let's find the strength of the total force. We'll use our version of the Pythagorean theorem, plug in our x component forces and our y component forces, crunch the number in the calculator, and we find out that the total force acting on the plane is 6,694 newtons. Now let's move on and answer the second part of this question. What is the direction of this? So we're going to find the direction as an angle theta measured counterclockwise from the positive side of the x-axis. And for this we need to use our trig function, the inverse tangent. So theta is equal to the inverse tangent of the ratio of the y component divided by the x component. We plug our numbers into the equation, remembering to use the negative sign if the component is in the negative direction. Our calculator gives us an answer of negative 13.8 degrees. We know, of course, there's another possible answer, and that would be negative 13.8 degrees plus 180 degrees, which would give us an angle of 166.2 degrees. So is it negative 13.8? Or is it 166.2? For that, we need to look at our force diagram, and we know that 166 degrees lies in quadrant 2, up and to the left. The force vector clearly is not going up and to the left, it's going down and to the right. So in this section, our angles, if we measure them in a positive direction, are going to be between 270 degrees and 360 degrees. That means in quadrant 4, if we measure them in the clockwise direction, they're going to be between 0 and negative 90. So negative 13.8 degrees is what our directional angle is. So in this case, our calculator answer is the one that fits this physical situation, not the calculator plus 180 degrees. Well, this wraps up our podcast. So let's summarize what we learned. We learned how to use the physics Pythagorean formula to find the strength of the total force given the strength and direction of the component forces. We also learned how to use trigonometry to find the strength and direction of the component forces given the strength and directional angle of the total force. And finally, we learned how to use trigonometry to find the directional angle of the total force given the strength and direction of the component forces. I hope you found this information helpful, and have a good day.